Okay, so the first classic version of spanning tree, which has the code of IEEE 802.1d, the common classic spanning tree, sorry, STP protocol. Okay, it took about 30 in the point-to-point cases, up to 50 in the classic ring cases, seconds, just to finish its elections and process and to make all the ports up and running and the other redundant ports to make them alternative. Okay, so in order to speed things up, IEEE invented the 802.1w. You must know the codes, it's very important. Okay, which is called the rapid spanning tree or the RSTP. RSTP, there is no listening state, there is no blocking, only discard, forwarding and learning. I will tell you about them. There is no maximum age, only 3 for learning, 3 for forwarding, and this will make my 50 seconds become only 6 seconds. This is because of the topology change and the acknowledge. I believe it was the proposal and acknowledgement bits in the frame that in the BPDU message, which BPDU messages are some special types of messages that are sent and negotiated only between switches. So it's a special language of switches. So switches do talk between them by sending BPDUs. BPDUs. Okay, so the BPDU that an RSTP sends has 2 bits, the proposal and acknowledgement bits. This is what makes it decide which ports to make it up and which port to disable. It's the same concept of max and priority. Okay, lowest priority and low MAC address and interface number, the same thing at all. Okay, but just to avoid the needing for the maximum age and to make the timing much lesser of the learning and forwarding. Okay, so this is for the topology change. In case a topology change happen, I don't believe all these details are required from you in the new CCNA. You will use only the proposal and acknowledgement bits in the BPDU that an RSTP enabled switch will use, and this will make the process takes okay up to only 6 seconds. Okay, so now you have your discard state instead of the disabled state. After the discard, all the interfaces will be learning, no listening is needed for now in the RSTP. After the learning, it's either there to become forwarding, oh god, forwarding, or go back to become discarding. So no listening and no blocking state in RSTP, only these 3 states. No maximum age timer, no 20 seconds of delay, only these 6 delays. That is what makes the RSTP very fast, okay, and very useful when they invented 802.1w. Okay, this can be enabled. You are not required to know how. The blueprints only mention that to explain the need for spanning tree and its versions, and that's it. Okay, so this is the RSTP, the second version of spanning tree. Okay, 802.1w. Okay, this is the delay instead of 50 seconds. What's the big benefit of redundancy then? If spanning tree is blocking ports, there is a benefit. There is some type of redundancy. There is some alternative port, but what does this sentence in our slide means? That when I have this topology and these 3 departments or three buildings connected together, and there is a redundancy between them, and spanning tree causing one of the ports to become disabled. Okay, so this building uses VLAN 10 and 20 this building uses maybe VLAN 10 and 30, and this building maybe here is using VLAN 20 and 30. Okay, so to VLAN 10, in order to communicate with the VLAN 10, it must cross this way. At the same time, VLAN 20, in case it wanted to communicate VLAN 20, it needs also to cross in this link. So this poor guy in here, this link is for at the same time carrying both the traffic of VLAN 10 and 20 at the same time. So maybe if it was a fast Ethernet port, it has only the capacity of 100 megabit per second of transmission speed. And these two VLANs, maybe one of them will cause us 80 mega and the other one will need 40. So we cannot afford 120 because these two VLANs and crossing both of them are using this cable, while at the same time this cable is disabled. So this is sad because I have extended this cable, I'm sorry. It cost me money, time, effort, and geographical spot just because of redundancy, but I want to make use of it at least where, or at least when I'm in the normal case of there is no problem, there is no layer 1 problem, every cable all the cables are up and running, so I need more bandwidth, I need to make use of this. Okay, so what was invented by Cisco was the per VLAN spanning tree. Okay, per VLAN spanning tree. This brilliant feature will virtually, more than a virtual LAN, but virtually in the virtual LAN world, will make a root bridge and an election process happened and applied for each VLAN separately. There will be a root bridge for VLAN 10 and maybe it will be this one, because in the normal case maybe I have this one is the root bridge. Okay, maybe this one in this scenario is the root bridge and it's causing this interface to be disabled. PVST will allow me to make this switch 2 is the root bridge for VLAN 10, and since it was a root bridge, okay, for VLAN 10, then VLAN 10 will see this port as designated, not blocking, not alternative, and this port is designated. So VLAN 10 traffic will go this way. Okay, virtually and really this will happen instead of going this way. And I will make this one is the root bridge maybe for VLAN 20. So VLAN 20 will see these two interfaces are its designated ports. So it will forward traffic for VLAN 20 only from here and forward traffic for VLAN 20 from here. But for VLAN 10, it thinks that it must forward it this way because this port is disabled. Okay, so per VLAN spanning tree will do establish a spanning tree for each VLAN. So when you hit show spanning tree, it will say for VLAN 1 the default, this switch is the root, these ports are disabled, these ports are designated, and these ports are the root. Okay, for VLAN 10 in the same device there is another root bridge and another ID, another priority, and another ports that are designated forwarding and disabled. Okay, for VLAN 20 also, for VLAN 30 also, for each VLAN there will be a separated single tree, okay, that have the decisions of which one should be up, which one should be down. This is the huge thing of the PVST, which each VLAN can have an election of its own, each VLAN will have its own route. Things are much better now. But if in the future a cable or maybe an interface went down, then we will go back to the same concept of the classic common spanning tree, and congestion or maybe bandwidth or link problem will occur. But as long as all my interfaces are connected, are connected and up, then things are awesome. I will make use of all of them. Okay, so this is the concept of spanning tree that Cisco invented and improved. Other vendors do have their PVST but in another name. This depends on the rights of the copyrights. Okay, Other vendors do have their VSTP, okay, not PVST. This is another naming for other vendors. In case we made other courses, I hope we will make other courses for other vendors and certificates. We will mention all of that and compare it. Okay, so after that, this is a classic PVST. Okay, that takes a lot of time for decision for each VLAN. So Cisco improved it by creating a rapid per VLAN spanning tree plus, which has the same speed of the RSTP. In a matter of 6 seconds only, you can decide and build trees for each VLAN alone, and everything will go up and running. Okay, so lastly, there is the last version, this one, which has the important code. I love this one very much, okay, especially in my work previously. 802.1s. Okay, this is the code of 802.1s. So now it's called the MST, the multiple spanning tree. The multiple spanning tree had made things much easier. You will not need to create specific spanning tree. You will not be in the need of creating a tree for each VLAN alone. Now you will create what's called instances or groups. After that, you will join some VLANs inside this single instance, and then only create a tree for this instance, which will automatically create the tree for these 5 VLANs, okay, and will join them inside it. Okay, so multiple spanning tree is the same, has the same concepts of PVST, but instead of doing a tree for VLAN 10, 20, 30, and VLAN 50, 60, 100, maybe VLAN 1000, 2000, 3000, or whatever, I will create a group, maybe instance number 1. Inside it, I will put these VLANs. After that, I will decide which one. I will manipulate the priority of a root bridge, okay, and will decide which switch will become the root bridge for instance 1. So this switch will be eventually and immediately become the root bridge for these 5 VLANs at the same time. And I will create instance 2 and instance 3 and so on. But the VLANs that I have, this is important information for you, okay, just in case it wasn't needed from you, but you might need it in your work. Just in case maybe I have these VLANs in my switch, maybe VLAN 2, 3, 4, 5, and VLAN 10, 20, 30, and 40, and maybe VLAN 100, 200, 300. Okay, I have grouped these in instance 1. I have joined these in instance 2. What will happen to these 4 VLANs if I did not join them in an instance? There is a default instance 0. Okay, sometimes it's called the CST, okay, or instance 0, common spanning tree, or instance 0. This is ready just to serve the VLANs that you haven't joined in a group. So instance 0 is there by default to join the groups that you haven't take it away for a special instance. Okay, so this is the big and importance of MST, the multiple spanning tree. It has the code of 802.1s. I must mention for the third time that codes are very important. Okay, so this is all the versions that you need to know about spanning tree. Let me clear this. What we have finally is just to mention 2 terms and 2 type of ports that you will face after you implement spanning tree using whatever version of them. There is something called H ports. I believe it's used only with RSTP, and port fast also. Okay, H ports are the ports that you don't want them to be involved in the election. When you operate, maybe this port is going to a server. Okay, so you don't, once you operate these switches, you know that all the interfaces will go in the listening state. After that, the learning, maximum age first. After listening, learning, forwarding. This will take maybe 50 seconds. Okay, so edge ports are the ports that I want to keep them always up, and I don't even want to involve them in the spanning tree. Okay, this is not connected to a switch, and it will not cause the broadcast storm problem or loop or anything. So this is maybe connected to an end device. Mostly it will has the naturality of an access port. Okay, it's not a trunk port carrying many VLANs that have this problem, even if it was a PVST or any version or even MST. Okay, so this port shouldn't be involved in the election and shouldn't wait for 50 seconds in each time a spanning tree problem occurs. Okay, so there is a problem here. So all of these ports will become listening and learning, after that forwarding or backup. So this port shouldn't be involved in all of this mess and headache. Okay, so I will go to this interface in this switch and make it an edge port. Sorry. Okay, this will take this interface out of the topology of the tree and the election process and all this mess and delay, and we'll make it separate. And when you initiate the command of show spanning tree in this switch, only these two involving switches will appear, involving ports, sorry, will appear. This port will not appear in the spanning tree show command. Okay, so this is the edge port. The port fast is another concept. The port fast is a port that is involved in the tree, involved in the process of spanning tree, but you want this port, maybe it's headed to a important customer, maybe, or some bank or some important customer or a company that you are providing service for them. Okay, port fast, when you choose the port to become port fast, this port fast is involved in the spanning tree. Okay, this will prevent the delay of the maximum age and learning. This will automatically make the ports always forwarding. Even if some elections change, this will automatically again become forwarding in every time. It will not take 50, not even 30 seconds for the election process delay to become forwarding again. Okay, so this is are the main differences between edge ports. Edge ports are out of the spanning tree and out of the process and election totally. Port fast is a spanning tree port in the topology, but it must be fast and always forwarding. Okay, so these are the versions. This is the fourth video of spanning tree. I believe we have finished 4 videos and more than an hour, okay, of spanning tree for discussion, concept, and verification. There is no implementing or configuring in spanning tree required from you in the new CCNA. Only these concepts are required from you. And for any discussion or any question, please comment below in the videos in our channel on YouTube III. Okay, like and subscribe us, please. Okay, to follow us to know the everyday new videos that we are uploading and working recording every day. Okay, and for anything in the performance in the channel or even in the material, just comment below and we will be glad to help you and improve it. Okay, so thank you for watching.